Okay, welcome back. We're going to talk about in this video a new topic that we've never talked about before, not even in first year chemistry. So please be paying attention, follow along in your guided notes. It's a very short video. It's just, we're going to talk about a new topic. It's called percent composition. So here we go. So mass percent, you're supposed to write down the definition for mass percent. It says it's the percent by mass of a component of a mixture or a given element in a compound. After we go through some example problems, that'll make sense. But it's just a percentage of the element by mass. To find the mass percent of an element in a compound, you first find the mass of that element and divide it by the total mass of the compound. And then you times it by 100%. Just like you would find percent on a test, you would take the number that you got right, divide it by the total number on the test, and then times it by 100. Same thing here. It's exactly the same. Here's an example problem that I want to go through with you guys. It says, in the molecule ethanol, which is C2H5OH, what is the mass percent of carbon, then of hydrogen, and then of oxygen? And so let's do that together. Run through that real quickly. So first of all, what I always like to do is find the total mass of the compound. So it's molar mass, just like we've been doing all along. Carbon, I'm going to do it up here. Carbon is 12, if you look on the periodic table. But we've got how many carbons? Only 2 carbons, all right. So 12 times 2, which is 24. Now let's add up the hydrogens. Hydrogens has a molar mass of 1, but we have 5 of them. So that's 5 more. Oxygen, actually we have 6 hydrogens, don't we guys? So that's going to be a total of 6. Okay, yeah, I forgot to count this one here, so there's 6 hydrogens. And we have oxygen, just 1 of them, and 1 oxygen, if you look at the periodic table, is 16 grams. We only have 1 of them, so that's another 16. So let's add up the total in this compound. 24 plus 6 plus 16 is 46 grams. 46 grams total. Now, if we wanted to figure out the mass percent of carbon, let's see if I can slide this out of the way, of just carbon, we would take, so for carbon here, let me do it over here on the top left here. So carbon, in this compound, 24 grams come from carbon. Divide it by the total in the compound, which is 46 grams, and then you're going to times that number by 100. So let's do that. 24 divided by 46, and then times by 100. Reuben, what'd you get?
Hold up. I got 52.17.
Yeah, let's just round to the nearest whole number, but you're correct, Reuben. Good job. 52%. So what does that mean? If we're talking about the mass of ethanol, C2H5OH, this molecule right here, 52% of its mass comes from which element? Carbon. And so that's kind of cool. 52% of the mass, more than half of it comes from carbon. Now let's figure it out for hydrogen. Okay, hydrogen. I'm going to do the same thing. The total from hydrogen in the compound was 6. So I'm going to go 6 divided by the total, which is 46, and then times it by 100. So 6 divided by 46, and times by 100. I'm finding that it's 13%. So the mass from hydrogen, not that much. Only 13% of the mass in ethanol comes from hydrogen. Okay, now let's do it for the last element in this molecule, oxygen. Okay, oxygen in this molecule had 16 grams. Total in the molecule was 46. We do that and then times by 100. 16 divided by 46. 34.7, but I'm going to round that up to 35. 35%. What you'll notice in the end is that it should add up to 100%. So if we took 52, added that to 13 and 35, that should add up to 100%. And it does. So that's very easy. Mass percent, or I call it percent composition. Okay, we're going to run through an example problem here. It says the chemical composition of sand. Sand is one of the most abundant molecules or compounds on the Earth's crust. Sand, if you look at its chemical formula, is SiO2, silicon dioxide. So we're going to determine the percent composition by mass for each element in sand. Okay, let's try that. So what do we need to do first, guys? We need to figure out the total mass of the compound. What's the mass of silicon? So Si. On the periodic table, it's number 14. It's 28 grams. We only have one of them, so I'm just going to keep it as 28 grams. Okay, oxygen is 16, but we got two of them, so that's 32. Whoops. 32 grams. Okay, so if we take 28 grams and 32 grams, we're going to add them together. The total mass of that compound is 60 grams. So it's said to determine the percent composition by mass for each element in sand. So let's do it for silicon first. Si. Okay. The total mass of silicon in one compound is 28. The total for the whole compound is 60. So we take 28 divided by 60 and then times it by 100. Let's do that real fast. 28 divided by 60 and times by 100. 46.666. Okay, so let's round that to the nearest whole number. It's going to become 47%. So 47% of sand is silicon. Now, since there's only one other element in this compound, we can easily just subtract one. Well, take 100 and subtract 47. But let's see if it works out. Okay, oxygen. The total in this compound that is from oxygen is 32 grams. So I'm going to take 32 and divide it by the total mass of the compound, which was 60, and then times it by 100. So 32 divided by 60, and then times it by 100. I get 53.333. If you round that to the nearest whole number, it's 53%. And if you want to check yourself and make sure you did it right, these two numbers, or the numbers that you get at the end, should add up to 100%. And it does in this case, so we know that we're right. So if you look at sand, its chemical formula, the percent by mass, most of the mass is coming from which element, guys? Oxygen. Okay. And that seems a bit strange because oxygen, when we think of oxygen, we think of it as a gas. But it's not always a gas. When it's bound to silicon, it makes sand. So. Okay, very good. Very easy stuff, right? I don't think this is too complicated. I got a practice problem. We'll end here. Practice problem number 36. I want you guys to figure out the percent composition of all the different elements in this molecule. So I'll give you a second to do that. If you're watching on the video, hit pause and see if you can't solve this, and then hit play later on. We'll see if you get it right. So I'm going to work it up here. Those of you in class will continue to work it. But we first need to figure out the total mass of this molecule. Okay? So I'm going to do that up at the top left corner. So we've got carbon. We've got 10 of them. And each carbon, if you look on the periodic table, carbon has the atomic mass of 12. Okay, so 10 times 12 is 120 grams. So 120 grams come from carbon. Let's do hydrogen. I've got 14 of them, And each hydrogen on the periodic table has the atomic mass of 1. So that's 14 grams. And we have one oxygen. Oxygen on the periodic table has the atomic mass of 16. Okay? So if you look, that looks like it's going to be 30 plus 120 is 150. 150 grams. Now this is the total for the molecule is 150 grams. But it wanted us to break each element and figure out its percent composition. So let's do it first for carbon. I'll do it at the bottom here. For carbon, you take the total from carbon, which was 120, and divide it by the total for the molecule, which was 150. And then we times that number by 100. So 120 divided by 150 times by 100 gives me exactly 80. So that's 80% of the mass of this molecule comes from carbon. That's quite a bit. Okay, let's move on to hydrogen then. Hydrogen, now the total mass from hydrogen in this molecule was 14 grams. So we take 14 divided by the total, which was, again was 150. And then we times it by 100 at the end. Remember to do that. So 14 divided by 150, and then times by 100. And that gives me 9.333 repeating. So I'm just going to round that to the nearest whole number, which is 9%. So not much of the mass is coming from hydrogen. We would expect that because hydrogen only has the atomic mass of 1. Okay, now let's move on to oxygen. Oxygen's total mass in this molecule was 16 grams. So that goes on top, divided by the total mass of the molecule is 150. And then times it by 100 to get a percent. And I'm getting that it's 10.666 repeating, so let's round that to the nearest whole number. You round 10.66 repeating, you'll get to 11. Okay, and if you look here, if we added up 80, 9, and 11, we would come to 100%. So that's just a good idea to do at the end of these problems to make sure that you did it correctly. Anyway, that is percent composition. We're going to pause the video or stop it here because you now know enough to do the worksheet in the student workbook. It's called percent composition worksheet. So take a second and we'll complete that worksheet, and hopefully that helps.